At SOLIDWORKS World 2018, the shop floor showcase process began by manufacturing the design part on-site with a Haas machining center and lathe. Now, before these parts were being manufactured, CheckMate, which is fully integrated with SOLIDWORKS, was preparing for the inspection process. You can see the MBD PMI on the left in the dim expert tree, and the black annotations and the red SOLIDWORKS inspection balloons in the graphics area. CheckMate reuses the feature and balloon names and tolerances by adding measurement attributes. With the press of a button, CheckMate repurposes the PMI into feature measurements in the CheckMate programming browser over on the right. And of course, the red SOLIDWORKS inspection balloon names are also incorporated into the feature measurements. But you don't have to use the Auto MBD button to generate the measurement features. You could create the feature measurements of your choosing from the measure ribbon. CheckMate will still reuse and repurpose the MBD PMI in those features too. You have full control of the program, from editing features by double-clicking on them to changing the order using drag and drop. The program browser is a powerful and simple editing tool. With CheckMate for SOLIDWORKS, programming time is easily cut by 90%. Origin partnered with 3D Infotech to demonstrate CheckMate's inspection process using a 3D scanning system. As you can see in the picture, the first step was to scan the prototype part. We still have the feature measurement program with names and tolerances from the MBD PMI and nominals that CheckMate determined. This list of measurement features will be used for authoring the soft gauge. The STL of the prototype was imported into CheckMate as a color map to calculate the matrix required to align the data to the part. There are many types of color maps. At the flip of a switch, you can select the color map that you'd like to see, average of multiple parts, and statistical color maps, including range, PP, PPK, and standard deviations, or just a single part color map like we used for authoring the soft gauge. Then we used the STL digital part and extracted all actual data for all of the features in our program or soft gauge. After loading the actuals, we used the SawFit solver. Here you can fit to the datums, fit to the secondary datums. You can even perform complex GD&T patterns if needed. After finishing with the SawFit solver, we used one of CheckMate's Excel feature report templates and created a report. Now, after doing all these previous steps, we're going to have CheckMate remember them all in a script file that we call the soft gauge. This soft gauge file will be used automatically on the 3D Infotech scanner after a part is scanned. The 3D scanner begins scanning the production parts, creating the STL digital part for each. As soon as the part is finished being scanned, the STL digital part is automatically evaluated. Whether simple deviations or complex GD&T patterns performed by SawFit, the authored CheckMate soft gauge performs its evaluation. We finish with an inspection report being automatically generated. The advantages of this programmable, reusable gauging solution provided by 3D Infotech is that there's no purchase of a hard gauge required, no cost to store a hard gauge, and no additional cost of calibrating a hard gauge. At the shop floor showcase at SOLIDWORKS World 2018, Origin's CheckMate for SOLIDWORKS demonstrated the concept of maintaining the digital thread for quality and manufacturing engineers, all inside of SOLIDWORKS.